Welcome to Study Loop.
In this question, I'm asked to describe the types of solute-solvent interaction. First, I have carbon tetrachloride in benzene. So carbon tetrachloride is a nonpolar molecule because it has a central carbon atom with 4 chlorine atoms coming off of it, all evenly dispersed. So this, even though each bond has a dipole to it, the entire molecule does not. Benzene is also a nonpolar molecule. So it's 6 carbons connected by single and double bonds. So at each vertex, I have a carbon atom. And it's also symmetric, nonpolar bonds. So this is a nonpolar molecule with another nonpolar molecule. When those two types of molecules interact, what you have are dispersion interactions. In part B, I have methanol in water. So methanol has this OH group. So if we look at that molecule, we've got carbon with, these 3 hydrogens connected to an oxygen atom, which is connected to a hydrogen atom. Now, this part of the molecule, the OH group, is able to make hydrogen bonds, especially to something like water. So as you know, water forms hydrogen bonds. And so what you'll have is hydrogen bonding between the OH group and the methanol and the oxygens here. I actually drew that wrong. It should be bonding between that oxygen and this hydrogen, or between this hydrogen and the oxygen is where the hydrogen bonding takes place. In part C, we're given potassium bromide in water. Now, potassium bromide is an ionic compound which separates. When you put it in water, it dissolves and forms K+ ions and Br ions. So these are ions that interact with the polar water molecule. So water is polar. It has this dipole moment. So what we have is an ion dipole interaction. Then finally, for hydrochloric acid, HCl in acetonitrile, notice that there's no part of these molecules can form hydrogen bonding. So what we have is HCl, which is polar, right? It has this dipole moment, and acetonitrile, which is also polar. So we've got this very electronegative piece. We've got a dipole moment that goes this way. So we've got 2 dipoles, the dipole in the hydrochloric acid, the dipole in acetonitrile, and thus we have a dipole-dipole interaction.